Hi, welcome to this video. This video contains lectures of the first two modules of my 5-star rated Udemy course on Angular 2. And it will walk you through the very basics of setting up your Angular 2 application with the Angular 2 CLI and then creating your components and using data binding. By the end of the video, you'll be able to create your first Angular 2 applications and not only know how to create it, but what you're doing there. If you enjoyed, definitely have a look at my full course, to which you'll find a link in the description. And with that, I wish you a lot of fun with the video. Let me quickly go over what Angular 2 actually is. It is a framework to create single-page applications. Now that, of course, raises the next question. What are single-page applications? Let's first have a look at a traditional web application, which means a server-side application. We have a user who uses the client, or who is the client, and we simulate this, for example, by using a browser, which is what we do all the time when we access the internet. We also get a server which holds our business logic, our data, and stores our website, renders our website. When the user clicks on a link, for example, the client will send a request to the server, and the same is true when we enter a URL, for example. And the server will handle this request and will send back a response. And in a traditional web application where we only have a server-side language or framework, we would send back a response which contains HTML code which the browser should render and finally view to the user. Now, the problem here is that we got a lot of requests to the server with this approach. For example, we might visit example.com. And this would issue a request, server sends back HTML. Then we decide to visit example.com about request response, example.com account, request response. And you get my point. For each different URL, or we don't even have to switch URLs, for each request where something has to change, we probably have to query the server to get back the new data or the new view we want to show to the user. And with this approach, we spend a lot of time sending requests and getting responses. The server has to work with that. The data has to travel through the internet. So that is a lot of time that is spent on the task. And this in turn will lead to a slow feeling of web pages. Do you know what happens if you use the apps on your iPhone or on your mobile phone in general? It feels very, very fast most of the time. And we want to bring that feeling, that app-like feeling, to the browser too, where we don't have to load new pages upon each action. Therefore, in a single-page application, the user still clicks a link, and this is handled by the client. However, the client handles that on its own and will re-render the HTML page through JavaScript. So the server is totally left out here, if it is possible, if no data from the server is needed, of course, and the client can handle all that on its own. That, of course, is much faster because we don't have to send any data over the internet, we don't have to wait for a response, we don't have to render that response. Everything is done within the browser. Of course, there are some times where we have to send a request because we might need some data from the server or some business logic which we can only store on the server. In this case, we will send a request and we will get back a response, but besides initial loading and server-side operations, which are absolutely necessary, we won't need that. And if we do need it, we will do it asynchronously, which means we still re-render the page instantly to the user and we will wait for new data to arrive and then incorporate that and, well, re-render the view again or whatever is appropriate. This leads to a different count of requests which we have to handle by the server. We might visit example.com and we will need to query the server to get the initial HTML file, which will hold our single-page application. However, for the next request, when we visit the About page, we might not need the server, so no request is sent here. If we access the account, we might need some user data, so here again we would make a server request. But as you can already see, we saved one request and with that a lot of time. And even at the times where we do send requests, especially the account page here, we still provide the instant feeling or this very reactive feeling to the user because we will handle the response data asynchronously, as we are able to instantly re-render the page through JavaScript. Therefore, Angular 2 handles the incoming user requests or events, which are sent through URL changes or DOM or mouse events issued by the user. It then parses the URL to route appropriately, and all is done on the front end in the Angular 2 router. No request is necessarily sent to the server here. And finally, it renders this new page by changing the parts of the DOM which needs to be changed. And the DOM, of course, here refers to the document object model, so the HTML code in the end. And that is done through JavaScript and therefore feels very reactive as it runs solely in the browser. All of that is done through directives, components, data binding, and if you're not sure what all of this means, well, that is what this course is about. Great, so now that you learned what an Angular 2 application is, why you could use Angular 2 as a solution for your web project, and at least in theory how it works and that components play a very important role, I think it's time to make the step from theory to practice and start with the first application in this course. So let's do this. For this application, I'll of course also set the basics, which we will need for all the other projects and examples throughout this course. So the bare minimums your system should have to, well, create Angular 2 applications. But no worries, it's really easy. It's only one thing you'll need for this course, and that is Node.js. So head over to nodejs.org and then simply download the latest version for your operating system. So simply click this link and then save it wherever you like. Once this is downloaded, make sure to head through the installer and install it on your operating system, and you're good to go. Now, you might be wondering, why do you need Node.js? Because we're creating an Angular 2 application, not Node.js, right? Well, we need it for two reasons. One reason is, yes, we're creating an Angular 2 application, but that needs to be served from a tiny little server as well. And, well, Node.js is capable of running such a lightweight, simple server as we will need it. The second reason is, throughout this course, I will use the Angular command line interface, or the Angular 2 command line interface, to create all these examples and several, well, components or general pieces of those applications. And you'll learn it throughout this course. Now, no worries, if you don't want to use the command line interface, all the code we write works exactly the same way in your custom setup project, and all the code is in one single source folder. So you're easily able to convert, well, the code you see here or the structure you see here into your custom workflow. Additionally, I also have a complete module on setting up your own workspace and workflow without the CLI. However, the CLI makes it real easy to create projects, and that is why I'll use it. So as mentioned before, for the CLI, we'll also need Node.js since, well, we need Node's package manager, npm, to install the Angular CLI in the first place, and the CLI itself will also need Node to, well, do all the magic for us. So enough of the talking, let's install the Angular 2 CLI then. This can easily be done from the terminal or command line interface if you're on Windows. And since you installed Node.js, you have npm, Node's package manager, available. Therefore, the only step required is to run npm install -g to install it globally on your machine, Angular CLI. Now, this will work on Windows. If you're on Mac or Linux, you might need to add a sudo at the beginning to give this the right administrative rights. Then hit enter, and well, here on Mac, I'm prompted to enter my password, so I'm doing this real quick. And then this will install the Angular CLI for me. Now this might take a couple of seconds, and I'll see you once this is finished. At the end, you should see something like this. Of course, the version might vary whenever you watch this video, but it should finish without an error. Then, in the same terminal or command line window, navigate into the directory where you want to host all your project folders. Once you are there, simply run ng. This will, well, trigger the Angular CLI we just installed, new to create a new project, and then the name of the project, which will also be the name of the folder. So I'm going to call it first app. Now this will automatically install a couple of dependencies and so on. It will also take some seconds. So I'll be back once this is done. See you then. So now the setup here finished, and the Angular 2 CLI automatically creates a tiny little app for you. So let's have a look at this. We can easily start up our little web server I was talking of earlier, also managed and created by the Angular CLI, as well as our app by typing ng-zerth. This will, well, first we have to navigate into our newly created folder though. So now ng-zerth. This will spin up this server and also keep the server running, and whenever you change something in your app, it will live update, so you don't have to hit the reload button. But we're not at this point yet, so let's have a look at our application first. Over in the browser, I'll head to localhost 4200. This is where this app is hosted at, and you'll see first app works. Yay, you created your first Angular 2 application. Though I see your point that we didn't actually do that much. So let's dive into the code and change a little bit. So I opened this project in WebStorm, my favorite IDE for Angular 2 development, since it ships with great Angular 2 and TypeScript support. However, you may of course use whichever editor or IDE you prefer. I know that Visual Studio 2015, which is free, at least the code version, so this basic version, offers good TypeScript and Angular 2 support, or you might choose Sublime Text or Atom 8 editor with the right plugins. That will certainly work as well. Anyways, so we got this project structure, and whoa, that's a lot. In one of the next lectures, I'll talk about this structure, at least at the very basics of it, and in the Angular CLI module at the end of this course, I'll go into a bit of more detail here. The most important thing for us right now is to know that in this dist folder here, the compiled and finished code will live, and in the source folder is where we added our application. So why do we have those two folders? Well, you'll see this in a later lecture when I talk about TypeScript, but generally we will write our code in TypeScript, not in JavaScript, and therefore this will need to get compiled in order to run in the browser, which is only able to serve JavaScript. This is the reason. So therefore, here in this source folder, we see our index.html file, which is the file hosted by this mini server, and we have this app folder. Now, as I said, I'll come back to the structure. First, let's have a look at the app folder. Here we have this first app.component.ts file, and we got this HTML, the CSS, and this .spec.ts file. Well, .spec.ts is for testing purposes, and we're not having unit tests here, so I'll get rid of this. The other files here are important though. If I open up this HTML file, this might be the one we see, right? Well, we got H1 and then this title thing in the middle. If we have a look at our running application, this looks like a H1 tag, but it's not saying curly brace, title, curly brace. Instead, it says first app works. Well, that's because this is Angular 2's template syntax, and here we're using string interpolation, a technique you'll of course later learn in this course. So basically here we're outputting some dynamic content. Where does this content come from? Well, from this first app.component.ts file, which is the TypeScript code, which will again later get compiled to JavaScript to run in the browser. So this is the actual logic of this component. And whilst it doesn't look that much code here in this file, it's quite important. We get this component import here from the Angular library or framework, which basically allows us to make this class a component by adding this add component decorator. And again, I'll come back to that in the component module. This is just the first app here. Then we basically have some configuration for this component, and the two most important ones for us right now is the selector, first app, and the template URL, first app component.html, which of course is the HTML file I just had a look at. So here, this seems to be the file which gets loaded, and first app selector seems to be important for loading this component here. And you will find the selector in the index.html file, which is the file served by the server. Now here's a lot of code at the top, and that's basically all from the Angular CLI, making sure that, well, the live reloading is working. Then here, this part is responsible for loading all the dependencies, the imports we need to make our application run. But then here, with system import, system.js is the module loader we're using in this app. So basically a program making sure that the right files are getting loaded. We're importing main. Now, this will basically start our app, and I will talk about this in the component section. However, here you see this first app thing, and this certainly isn't a default HTML tag. This instead is the selector we specified in this TypeScript file. So it looks like this selector is important here because it allows us to basically create new HTML components or elements, which we can place in our HTML code to load our components. Because this loading text here is certainly not what we're seeing. We're seeing the content of this HTML file. Well, and this dynamic content then inserted into the content, kind of. So this is what we see. And this indeed is how an Angular 2 application works. You create new components, new HTML elements if you want to put it this way, but it's a bit more as you will learn. And then you can use them in your code. Now, as I said, there is a bit more to it and you will learn this, but basically this is how this first application runs. And since we know that this HTML file here is the right place to change something, or since we're outputting some dynamic content, we search for this content, this title. Well, maybe you already saw it. It's here in this .ts file. Here, title, first app works. This clearly is the text we see here. So if we change this to, does this show up? And I save this, and all you have to do is hit Command or Control S to save. You will see that the browser already updated, and you see does this show up. Isn't that awesome? And this is how you generally work with that. It's live updating. And this is how you work with components. You can change some content in your class here, which you might output in the HTML file. Or if you don't need dynamic content, you may of course also enter anything directly into this file like, hi, I'm also displaying, which will give us this paragraph here. That's it for the first app, and I'm pretty sure this was a lot of stuff you probably didn't know yet, otherwise you wouldn't take that course. You will learn it throughout this course though, and this generally is how quickly you get set up with the Angular CLI. And in the next lecture, I'll go briefly over this structure, the most important things about the structure, and thereafter you'll learn a bit about TypeScript, and then it's time to get started with components. See you there. So as promised, just a quick overview over all the folders and files which were created by the Angular CLI. I will keep this brief on purpose because I don't want to bore you. If you're interested, check out the separate module on the Angular CLI where I will go through that in a bit more detail and also explain how to use the Angular CLI in general. Though you'll learn a lot of that by just following through that course. I made sure that, well, you're always on the same page as I am, and I'm not using any commands you don't know or understand. So if you're not interested into details about the structure right now, you may just skip this video. You're still there? Okay, so let's continue. I'll go through all these folders and files from top to bottom. Well, not through each file, of course. This config folder, very easy, holds some config, and you probably won't need to change anything here as it is mostly for testing purposes. The dist folder is the deployed or the build app. Angular 2 or the Angular CLI builds our application whenever we change something and save this file. This will then trigger the live reload of the browser. And the files which are actually served in the browser can be found in this dist folder. Therefore, we never write directly in that folder. We let the Angular CLI manage this folder for us. And we need this extra folder since we're using TypeScript, and this has to be compiled to JavaScript. The CLI also supports compiling SCSS, so SAS code to CSS if you want to use that. And anyways, there are some optimizations which need to be done. For example, we don't need all the node modules, all the dependencies installed here, but just some of them. And the required ones will be copied into this vendor folder here, for example, and all the development-only dependencies will be left in the node modules folder so that we don't upload unnecessary stuff on our server once we actually deploy the app. That's the dist folder. The E2E folder is for end-to-end testing and not interesting to us right now. The node modules folder holds all the dependencies of our project, including development-only dependencies. We need this for development, but as I said, for deployment, all relevant dependencies will be copied into this vendor folder in the dist folder. This public folder is empty. You could store any files you also want to copy into your dist folder there. So if you have some images, for example, or anything like that. The source folder, as I already said, is the meat of our app. Here we're creating our application. Here we're working with components, with TypeScript files, with the templates, and so on. And basically here we get this app folder, which holds all our TypeScript files and the templates of our components. And we get, well, this root folder with the very important index.html file, which is responsible for loading and starting our app. This is the only file which technically gets served by the server to the browser to be rendered, since we're creating a single page application. And we get a couple of other files. Now, I could talk hours about them, but basically the main.ts file is very important. You'll learn more about it in the components section. It's responsible for starting up our application, to give Angular 2 this initial kick it needs to, well, run and to identify that this first app actually is a component. So that's basically very important. This is the file which gets imported here. Main refers to main.ts, or later in the compiled version main.js, of course. System config is, well, responsible for configuring system.js, which is the module loader you see in action here. All these system commands. And while this file might look very complicated and long, it's very simple in the end. Basically everything down here, as this comment says, is managed by the command line interface and just makes sure that all the dependencies get imported correctly and are available to our application. And up here, well, nothing is specified. Here you can later on change some things if you add third-party packages, for example. And also check out the module on the Angular CLI to learn more about that. Well, this tsconfig.json file is important for the TypeScript compilation, and the default setting should be fine. But whenever you need to change something, but you should know what you do then, you can do it here. The typings.dts file, well, is important for two things. It declares one variable here, which is used in all the TypeScript files, which is important to not get compilation errors. And more importantly, or also as important, it imports a couple of typings. Now, what are typings? Typings kind of are the bridge between JavaScript libraries and TypeScript code. You can mix TypeScript code with normal JavaScript code, and indeed you'll often do. But if you want to use a pure JavaScript library, which was not written in TypeScript, you need kind of a bridge if you want to get compiler support and IDE support like autocompletion, so that basically the TypeScript code knows which types the JavaScript code uses, even though JavaScript doesn't have typings. And that's exactly what the typings files here will define. So this is generally optional. It would work without it, but you would get some errors. This is why this is here. Well, and that's all for the source folder I want to talk about right now. Now, the temp folder here is very strange, and basically this is needed by the Angular CLI during the build process. Nothing important for us. Typings folder, of course, houses the typings I was talking about when talking about this typings file. All the other files here also are providing some configuration for our project. Most importantly, the Angular CLI.json file and the Angular CLI build.js file, which allow you to, for example, when working with third-party projects, implement them here, or generally change the basic setup of your application. Like, for example, the prefix you want to set for each selector by default where your source file lives, and so on. But in general, you don't need to change anything here. So that was the, as brief as possible, overview over the structure. And I hope it's clear how all of that works. With that, time to continue with the next videos. So what's TypeScript? TypeScript is, as I said, a superset to JavaScript. It adds new features to the JavaScript language. Most importantly, types, but also classes, modules, and much more. That makes up TypeScript. And besides these extras, it is JavaScript with a bit different syntax, but not really that far away. In the end, the browser can't run TypeScript. Therefore, TypeScript will always be compiled into JavaScript, which is what the browser is able to read. Now you might ask, how can we compile something which is not included in JavaScript to JavaScript? Well, we can do that because for some things like classes, there are different ways to write it in JavaScript. And for things like types, which simply don't exist in JavaScript, we don't have strong typing in JavaScript. Well, this will be left out, but it's good to have it anyway because the TypeScript compiler will check those types and give us errors if we misuse types or use them wrongly. So we got this extra level of security, which is one of the biggest benefits TypeScript offers us. Because speaking of benefits, why would you want to use TypeScript instead of JavaScript? Well, there are some general reasons and some Angular 2 specific ones. The general reasons would be that you have that strong typing I just mentioned, which means that you set which property will have which type. For example, that a property should be a string. If you then try to assign a type which does not match, the compiler and probably your IDE too will give you an error. And that prevents you from making a lot of difficult to find errors, as you will get this check right out of the box at the beginning. So that's the biggest and most important feature, as tiny as it might sound, but it is not. Another reason is that you can use next generation JavaScript features today. For example, classes, imports and exports, so that modular multi-file approach. And as I explained, some of these things will be transpiled into today JavaScript, so prototypes and so on. And some things might be left out, but are still usable with the TypeScript compiler to give you errors and so on. Another reason would be that you get missing JavaScript features like interfaces or generics. Now, JavaScript doesn't have any similar thing. However, again, the compiler knows that we, for example, want to have an interface which forces us to implement a certain method and therefore can yell at us if we don't do that. And after the compilation step is finished, yes, we won't have that feature anymore, but we don't need to because we already checked that we fulfill it. So that are the general reasons. Now, if you're not convinced, and well, you probably should be, but if you're not, let's talk about the Angular 2 specific ones. Very importantly, documentation and support is mostly in TypeScript. And yes, this will probably be added for pure JavaScript in the future, but the majority of examples and articles you find uses TypeScript, so it makes your world a lot easier if you're using TypeScript too. The question is, why is that the case? Why is everything in TypeScript? Well, because the Angular 2 team chose TypeScript as the main language, so to say, for Angular 2. And of course they did this due to the reasons you can find on the left in the general part. And as all of this is the case, this course will use TypeScript, and I strongly encourage you to do the same. So with that, the question is, how do you use TypeScript? Well, with the Angular CLI projects, you don't have to separately install it because the project will automatically do that for you. However, you still might want to install it globally on your machine. And you can do this with the sudo on Mac, on Windows leave out sudo, npm install TypeScript -g command. And I will do this on my machine because you might need it in other projects which are not related to Angular 2, or, and you will see this in one of the next lectures, when using tslint, which is a little support helping you to write clean and well formatted TypeScript code. So I will quit my running server here for now, and install TypeScript by typing npm install g TypeScript, and I should add sudo since I'm on Mac, so I'll do that. Enter my password here real quick. And that will install TypeScript globally on my machine. And in my case, as I already had it, just update it to the latest version. So until now, you saw your first application, you saw how you could change a tiny bit of it. We went through the project structure and all of that, and that's nice, but what's actually happening in an Angular 2 application? What's Angular 2 doing, and how do we build an Angular application? Well, of course, with all these files, but what's inside those files? The core concepts of Angular 2 applications are components and directives, with components being directives. Now, what's that? Well, directives are instructions in the code, in the HTML code, telling Angular 2, which is the application running over your code, what to do. And components are such a very important instructions which tell Angular 2 how to render certain pieces of your application. So if we have a look at our browser window here and we're on example.com, well, we probably see a header with a products and about link, for example, and on the products page we might have multiple products, kind of a sidebar on the right, and all of these things here are components. Of course, they are living on a kind of a root component, a component holding everything together. That is the app component you saw in the first app lecture, where we had this app component being bootstrapped in the main.ts file, if you remember this, and that's the core, the root component holding your application. But then your application consists of multiple smaller components sitting on that root component. And that is the key concept of an Angular 2 application. When you're creating Angular 2 apps, you'll be building components. And component does not only mean HTML code, which is rendered in the browser, but also the logic behind that code. So handling user events, loading data, doing calculations, interacting with other components, because of course your components aren't standalone. They work together. So this is the key concept of Angular 2. And when you're creating an app, you'll be building components which, again, have a view, HTML code you see in the browser rendered as a web page, and the logic attached to that HTML code. And within each component, you may have references or selectors of other instructions, other directives or components, so that you build up your application of these building blocks, which then work together and make up your overall application. Because if we have a look at our web page here, we can basically identify a couple of components. We have our item components, we have the sidebar component, the header component, and of course the root component I was mentioning. Back in the project, this, as I mentioned, first app component here has this extra app because Angular CLI put this app there, because this is the root component being started in this main.ts file in the bootstrap method which loads up our overall application. So this is the root component holding other components, and throughout this module you will see how we create several components and let them work together. But for now I want to stick at this first app.component.ts file. In this file you can see we got a TypeScript class, which of course gets compiled to JavaScript as all the TypeScript code does. And this class has a name of first app component. This class has a property, title, which is of type string and says, does that really work? We're exporting this class here to make it available outside of this file too. So this is a module. This is automatically transformed into a module which we can import using the import statement, like we're doing it here at the top of this file for the component metadata we're importing from the Angular 2 framework. That being said, that's a very important step. This component metadata, which you see attached right above this class. You can see that we have an @ sign at the beginning, which indicates that this is a TypeScript decorator, which allows us to easily add metadata to a class. Now, rightfully, you may ask, what is metadata? What's that? What does it do? Well, metadata is basically some additional information you attach to a class which you can't or don't want to include in a class body, and which will tell JavaScript, or in the end Angular 2, what this class should be transformed to, or give it some additional information. Otherwise, this would be a plain normal class, and Angular 2 would not know that this is a component it should render to the screen, and so on. With the add component decorator, Angular 2 does know that, and it knows, okay, this is our normal class, and I will transform it into a component. I will use it like a component. Now, what makes up a component? Some of the things we define here in this component decorator. This component decorator takes a JavaScript object as an argument, as you can see, and then here we got 4 fields defined. Now, be aware that there are a lot of the other fields too, and you don't need all of the fields, all of the configuration for each component. It depends on what your component does, which dependencies or other things this component might have, and you will see them being added step by step throughout this course. This component here has a module ID, and I will come back to that in a second. It has a selector too, and this is the very important thing. This first app selector here. Now, what's that? What's this first app selector? This is the selector, the instruction. Angular 2 will search for an HTML code, and whenever it finds this instruction, this selector, it knows, okay, I should render this component in this place. Now, where does it search for it and where does it find it? Well, for this root component, which is started with the bootstrap command, it looks in this index.html file. And in this index.html file, you see this line here, first app, with the loading text between the opening and closing tag. Now, this clearly isn't a default HTML5 or HTML tag, right? There is no first app tag in HTML. Nonetheless, when loading the website, we're seeing this, does that really work, and nothing else, right? We're not seeing the loading text. Now, Angular 2 knows that this first app refers to this first app component here, because we're bootstrapping this application and passing this first app component. That's necessary for the startup of our application, and tells Angular 2, hey, look for this first app component in the index.html file. And it does look for it, and it does find it, because we have this tag here, and this tag matches this selector. That being said, this selector could be changed. It works like a CSS selector. So here we have just first app, and this would be similar to, let's say, h1. Now, h1 would select all h1 elements, and of course I'm not doing that here because I don't want to replace h1 elements, which is a default HTML tag, with my component, but I could do this. So back to this. I could also make this look like an attribute, like an HTML attribute. Now with this would no longer work with that code here, as I can show you if I restart my server, ngserve. And now if I reload my page, you're seeing this loading text, because now Angular 2 will no longer replace this first app selector here because it's not aware that it should. The selector is pointing to a different element. For example, the selector would now match a div which has first app attached to it like an HTML attribute. Now you see that doesn't really work here, because now this is matched as I replace the selector with an attribute selector. And again, I'm just using the normal CSS selector notation here. So nothing special. I'll change that back to tag selection, so that again, I'll be able to swap out this first app selector here. So that's the selector, very important as you learned. Next is the template URL, which refers to this first app.component.html file, which of course holds the HTML code which should be rendered whenever Angular 2 finds this selector here in HTML code. So basically right now with the selector and the template URL, we're telling Angular 2, whenever you find this first app selector as a tag, as an HTML tag in the code, take it, kind of remove it, and replace it with the HTML code you find in this template here. Though, of course, in the end, it does a bit more than just replacing it, but this is how you can think of it with these selectors. Now, you could also get rid of template URL and specify the template inline, which means in this file. If you want to write over multiple lines, you would use backticks, so 2 backticks, and now you could, well, create your h1 tag here, name it inline template to indicate that this is in the same file. And if I save this, you will now see the text inline template. Now I'm no longer using the external template here. I could get rid of this HTML file, and I will get rid of this testing file here too, since we don't need it yet. And I would have my template in this component here. Now the question is, should you do that or should you use an external template? It depends, but by the styling guide, it's a good idea to use an external file whenever you have more than 3 files or 3 lines of code in your template. So if I had this here, another line, that would still be fine. That would still be fine, but with that template, I should think about adding an external template file. However, of course, it's totally up to you in the end. The same is true for the style URLs metadata here. Style URLs takes an array listing all the CSS files you want to use to style this component. And here, an important thing on which I will come back to is that the style will only be applied to this component. So if you're styling your h1 tags in this CSS file, not all your h1 tags of the whole application will get styled, but only the ones you have in a template of this component. That's a very important concept to understand, and as I said, I'll come back to that. So here I'm referring to an external style sheet, and as I said, I could add multiple style sheets here, but I could also get rid of URLs and have styles here. This would still take an array of multiple strings, and then I could also use backticks to write over multiple lines and give my h1 tag, which I have here saying inline template, a styling of, let's say, a red color. Now if I save this, you'll see that the color changes to red. So that's all nice. Back to this module ID thing here. What's that? Well, now that we have the template and the styling inline of this component and no longer use external files, we would not need that. However, whenever you use external files, so template HTML file or styling CSS files, you will need this module ID thing here and set it up exactly like you see it here to allow Angular 2 that once it is in production and compiled and maybe bundled, to still find the appropriate external references, the appropriate external files, because of course the files are not in the same, the style and the HTML code is not in the same file but in another file, and to keep that relative reference and to not having to define absolute URLs here for template URL and so on, we can use module ID, which will basically tell Angular 2, hey, your external style sheets and template HTML files will live in the exact same folder as this compiled or minified or whatever class here module will live in. That's the key thing. So this module ID thing, this module ID metadata makes sure that the relative references to your external files are being kept. So this, as you can see, changed quite a bit. It doesn't look like the component set up when we created a new component. We got rid of the external files, and this still works. And this is how you work with a component. You configure it in this metadata, in this decorator. And as you can see, I'm not even using this title anymore, so I can get rid of that. And now I got an empty class. And all of my logic lives inside of this metadata, which shows you how powerful and important this metadata is. And metadata you'll always need is a template, because a component in the end always needs to have a view which can be presented to the user. That's the bare minimum it will need, and which you should make sure to provide, be it with an external file or inside of this component file here by just adding this template metadata. So this is how you transform a default TypeScript class into an Angular 2 component, how it is loaded through the selector here in the index.html file, and how you set it up or configure it with the metadata. That's all nice, but in the next lecture, we'll finally have a look at adding our own components. So in order to do this, I will open up a new terminal. And again, this is our normal terminal here, just in my IDE. And I will use the ng command again. So I'll navigate into my project folder. And then with ng generate, I can generate a new piece, so to say, of my application. For example, component. Later you will learn about different things you can create, you might use in your Angular 2 app. So I will create a component by using ng generate component, and then I give this component a name, and I will name my, let's say, other. Basically, other component will be the name at the end. Other, and then hit enter. Now this will create a couple of new files, and it will create a new folder too. As you see, it created this other folder. Now in this folder, you again find the same files you saw before. I'll get rid of this testing file. Then I got my HTML file, which just says other works, an empty styling file of which I will get rid here because I won't need it right now. And I will get rid of the style URLs in my component itself in the TS file. This ng on init thing isn't important right now. You will learn about on init and lifecycle hooks, what that is in the end, later. I'll also get rid of the constructor for now. And of that import here. So now we got, well, pretty empty file. As you can see, the selector was automatically set to FA other. That is because when creating this project, I added the prefix flag to the Angular CLI and set the prefix to FA, which makes sure that it prefixes all my selectors with this FA dash thing. Now, why is that important? Well, think about the importance of the selector. Angular 2 will replace everything that matches this selector with this component. Imagine you made a mistake and were to set the selector to article. Now, article is a default HTML element, and that probably wouldn't be that good. Now, let's say you don't make that mistake, but you name it Angular sidebar. Now, that certainly isn't a default HTML tag, right? Right? But what if you were to add another third-party library, and that library were to use the exact same tag? Now you would have problems again. So in order to make sure that you're not interfering with default HTML tags or third-party libraries, the solution is to make unique selectors. And a very good practice to make sure that your selectors are unique is to pick clear prefixes. This might be the abbreviation of your company name, the abbreviation of your project, of your first name, if that makes sense, whatever, but pick something which makes this selector unique. And then follow it by the name of this component. So other in this case, since I named this other component. So this is the file which was set up for me. And now I want to use this FA other selector. I want to use this component in my app component. So I'll get rid of another line and I'll add FA other. Should work, right? I'm using this other selector, FA other, which is the selector set up here. So if I save this and have a look at my project, I can't see it. Do you see it? We should see other works, right? But I don't see it. The reason is the component, first app component, doesn't know what FA other is. Like the index.html file wouldn't know what first app is if we would not tell it. And where do we tell it? in this bootstrap file where we tell Angular to start this application and start it with first app component. Now this will tell Angular to, oh, okay, now I'm aware of this first app component. So I'll have a look at this. I see that it has the selector first app. And now when I go over this file and find first app here, I know that this refers to this component. Now we're not doing the same in this first app component. We have FA other, but we're nowhere telling Angular 2 that this is a component, that it should look at a component. And it doesn't by default scan all our components, which is a good thing. So how could we tell Angular 2? Well, we're not doing that in the bootstrap method because our application is already running. The place to tell it is inside this first app component here. Because here is the template where we're using this component. Now remember that I told you that components are directives, instructions in the code telling Angular 2 what to do. So we're using such a directive in the template of this first app component. In order to tell Angular 2 that this is a directive, or put in other words, in order to let Angular 2 know which directives we want to use in this template, I add another metadata to this component's decorator. The directives metadata which takes an array as a value. Now this array just has a couple of references to the types of directives we want to use in this component's template. And here of course we only want to use one type or one reference, and this is the other component. So I will add other component here. Now this still won't work, and I could auto import it here with my IDE, but I'll do that by hand. I'll import something from the other folder. Now the something I want to import is the other component. And by the way, one of the style guide rules is to have an empty white space before and after your import module names here. So now this works. And I'm importing that from other and not from other/other component, which would work too, by the way. Now I'm importing it from this other component file. Without that, I'm just importing it from other, and this will default to this index.ts file. And in this file, I'm exporting this other component. Now that might look a bit complicated, because why would I have an extra file for that? Well, the reason is just if I add multiple components or things in general, modules, I want to export in this other folder, I would group them all in the index.ts file here, a concept called barrels, which allows me to organize my imports like that, just indicating or referring to this other folder and not to the individual files. This makes for shorter import statements, saves code, and makes it more readable, and is a good practice you should follow when writing Angular 2 applications. But the thing with the barrels was just a side note. The important thing here is, of course, that now I let Angular 2 know that I'm using the other component as a directive in this template here. And now Angular 2 will be able to identify this FA other selector. Therefore, you see other works now if you reload your page, or if you save it, it is reloaded automatically. So with this, we're now using another component in our first component. So we're nesting components. We're having this root component, which gets started by the bootstrap method, and which then holds our new component, FA other, or the other component, inside of it. So that's nice, but let's say we want to add another component, and this component should be a sibling of this FA other component. Now I could do this by repeating the command from before, and let me just name this another. Well, I could hit enter, and this would create a new folder, another, with all the files you're used to. However, I don't want to do that. I don't want to create a new folder. I want to be this component to be in this other folder. So I will just navigate into this other folder, and inside of this other folder I again run ng, and I could run generate, or I just run g, which is just an abbreviation for this, and then I could type component, or just use c, which is also an abbreviation. So ng gc, that does the same, as ng-generate-component does. And then what I'll do next is I'll add the name, of course, another. Then I will add a flag, which I'll call flat. And this will make sure that it doesn't create a new folder, but instead creates it inside of the folder you're in when executing this command. So the other folder in my case here. I also don't want to create this external HTML and CSS file here. Therefore, I can add the template or the flag inline template and the flag inline styles. I can also abbreviate those two flags to just write with one dash IT and IS. Now if I hit enter, you can see that it created two new files, and I'll get rid of the test file. So it didn't create an HTML or CSS file. And in this file here, I got an inline template, the inline styles set up. I won't need them here. I got a selector of FA and other, of course. I'll get rid of the other things here again. I won't need them right now. And that's that. Now, if I have a look at the index.ts file, I'll need to update this to make sure that I'm not only exporting other component, but also another component. Of course, in this case, from the another.component file. Make sure to not add the file endings here. You're not having .ts here at your exports. You don't need that. The same is true for the imports, by the way. So now I have this another component, and now in the first app component, I can just add another component, and I can add the import here too. That was this import grouping I was talking about. I'm now importing all of that from the other folder, even though the modules are technically in different files. And that's just because I'm preparing this in this index.ts file. So now I'm ready to use this another component. I'll add the selector, the HTML tag here, and now you can see another works. So this sibling component to the other component works too. And now you also learned how to quickly generate new components with the abbreviations and how you can switch between having them created in subfolders or in the same folder with inline templates or inline styles. It's a really important thing here. Now, one important thing to note is if I go to the other component or then to the HTML file, and I replace the paragraph with h1 and save this, you of course see that this is black, whereas the h1 in the app component is red. And that is even though I just set h1 to be red. I did not add any other selectors, making sure that this only applies to this h1 and then not to the other h1s. You could say, okay, it's a different component. It's clear that it doesn't get applied. But it's not clear. Normal CSS does no components, right? In your browser, you don't node components. You get one single HTML code. And how does it work that not all the h1 elements get styled if we set the styling here? This question is answered by view encapsulation, a concept introduced or used by Angular 2. If you go back to the browser, this is what our page looks like. And now if you only want to style the item components, let's say all of that are div containers, but we only want to style those div containers. We want to make them green. How could we do that? Angular 2 emulates a concept called the shadow DOM. The shadow DOM means that an HTML element has its separate DOM behind the scenes. So, for example, here, this article element with the h1 in it would have a shadow DOM behind it, where we apply the styling, like let's say setting the font size. But other h1 elements on the page won't be affected by that because they have a different shadow DOM behind them. Now, the shadow DOM is a concept which is not supported by all browsers, and therefore it would be unsafe to use that natively because, well, it wouldn't run in many browsers. So that is not the best way. But Angular 2 emulates the shadow DOM, which means it offers the same functionality also working in older browsers, which of course is great. So the emulation Angular 2 adds looks like this. We have a component which has its own shadow DOM behind the scenes, but we're not using the actual shadow DOM. Instead, what we're doing is, or what Angular 2 is doing, it adds this cryptical attribute to it, which of course isn't a default HTML attribute. And this cryptical attribute, as well as the cryptical attribute on the h1 tag, allows Angular 2 to identify that only elements with that attribute should get the styling defined in this component. And of course, that attribute will vary from component to component. And with that, Angular 2 makes sure that your styling is really only applied to the elements you wanted to apply. Because in the end, Angular 2 will add your styles in the head tag of the HTML document and add this attribute selector to it. But it's best to see this in action. So I'm in the browser, and if I inspect this red h1 tag here, let's increase this in size a bit. You can see this cryptic attribute I was talking of, right? And if you have a look at the other h1 tag, you don't see that. So it's only there on the one which is actually red. The other tag doesn't have it. Now, if we have a look at the head of this document, you see the style tag here, which was added by Angular 2. Now here we have the same rule we set up here. h1 should have a color of red, but Angular 2 added something to that rule. It added this attribute selector, which is a normal CSS selector, making sure that only h1 elements with that attribute receive a red color. And that attribute, of course, is the attribute Angular 2 added in the HTML code here to this component, or all the component child elements. Therefore, elements in another component don't receive the styling because they don't have that attribute. And if you would have a different styling there they would get a different attribute and a different styling therefore. So this is Angular 2's view encapsulation. And that being said, you can turn it off if you don't like that. You can turn it off. You'll find how to do that in a cheat sheet for this module, but that's the default and it's really, really handy to use. Now, can we use multiple components on the same page or in the same template? Of course we can. If I just duplicate this another component, you see 2 times another works. Now all that text here is not really that useful. So if I want to, let's say, change the another component a bit and no longer output another works, but instead let's say I would have an article here, and this article should have some styling. It should, let's say, have a simple border and then output some text between. So I would of course add the styles metadata here to set up the article styling. And I just add a little border here. And I just added a solid black border around this article. So if I now save this, you see that this works. However, maybe I don't want to have a dummy text in here, but I want to pass this text from outside. There are 2 methods to do that, and one of them is data binding, property binding, which you'll learn about later. But sometimes you have components which only are kind of the container for other HTML code. And in order to allow you to pass other HTML code easily into your component, you can do the following. Let's say I want to pass in another div. And of course, this is getting long, this template, so it would be better to outsource it to an external HTML file, but I just keep it here to have it all in one place for demo purposes. And then in this div, I would have an h2 tag saying hello, and then a paragraph saying world. Now, if I save this, I'm not seeing it here. That's all broken. It's not outputting this, what I'm entering between these tags. And the reason is, of course, as I said, Angular 2 finds these tags, throws it away, and enters the content of your component template. And that is important because otherwise we would still see this loading ... thing if that wouldn't be replaced. So sometimes we don't want to replace it though. So in this case, I want to keep it. Good thing is Angular 2 has a handy directive we can use for this. And by simply adding ng content like this selector, this refers to a built-in directive Angular 2 offers. Now this will render all the content being passed between the opening and closing tag inside of this component. Therefore, this now works. And if I add, let's say, something else for the second time I use this component, like let's say just a paragraph saying something else, you'll see that this gets rendered too. And this is a good way how you can create reusable containers which take other HTML code and embed that inside of them. So this is how you can use ng content to render this HTML code within other components. Now what happens if I change this h2 to h1? Remember, I'm styling h1 for this component here. As you can see, the styling gets applied here too, because, well, this is not defined inside this another component. It's defined in the first app component, and this is the component which applies the styling. So be aware of that you style the content you pass into the other component inside of the parent component, like here. So that's been a short introduction to components, templates, how you can use multiple components, and how you build up your application of components. However, we're still outputting static text until now, and that isn't the most important thing, or the most interesting thing, isn't it? So it would be great if we could interact with the templates and output dynamic data there. If we could let our components interact besides passing HTML code from parent to child. If we could listen to events in the DOM, for example. Those are all very important things, so time to get to that. So this is of course about data binding, which basically means interacting with data, interaction between templates and business logic. Data binding means communication. It means that our component body, the logic, the class, the TypeScript code, interacts with the component template, the view which the user sees. And our component body passes data to this template, and there are different ways to do this. You will learn all of them, of course, and listens to events. As I said, you will learn all of them. So which data binding methods do we know or do we have? We got string interpolation, which has the following, or this syntax, double curly braces, and then an expression which resolves to a string. And you already saw that in the first app where we output title between curly braces. Title was referring to a property of this component, which was a string. Therefore, we were able to output it because, as it's written here, the expression you want to output has to resolve to a string in the end. Another way would be property binding. And property binding means you're binding, which means sending data to properties in your DOM, in your HTML code. Now there are different properties available, 3 kinds to be precise. And I will come back to that. One example would be to bind to the disabled property of a button. This is a normal DOM property. And then you'll need an expression. And notice that we don't have curly braces here. We just have quotation marks. And between the quotation marks, an expression which resolves to the type this property needs. So for the disabled property here, for example, true or false. But for other properties, you might need an expression resolving to a string or something like that. Kind of the opposite of property binding, where you send data to a property, here for example to the button property, would be event binding, where you listen to events emitted from an element, from something. Here, for example, we're listening to the built-in click property or to build click event. And this click event is available on a button, for example. It's available on each HTML element. And then between the quotation marks, you have the expression you want to execute whenever this event occurs. Now note that expression means that you could also set up a method which should be executed here. Or if it's a very short logic you have, you just define it inline in this code. The last thing is two-way data binding. And two-way data binding, of course, was one of the most important things for Angular 1, which made Angular 2 so very, very successful and popular. Angular 2, by default, doesn't have two-way data binding. By default, all data flow is unidirectional, which allows it to run it so fast and circumvent some problems. Nonetheless, if you need two-way data binding, it's still there. And the syntax is the one you see here. Squared brackets, then parentheses, and then ng model inside of that. And as you probably see, it's the combination of property binding, where you use squared brackets, and event binding, where you use parentheses. And this, of course, is no coincidence, but instead, it makes sense to mix both syntaxes, because two-way binding, as the name implies, is two-way. It is property and event binding in one single thing. Now, ng model is the keyword here you have to use, and then between the quotation marks on the other side of the equal sign, you set up the model. Could be a single property, could be a more complex object, and a field of that object, which you want to bind to this input field here, for example. Now, this would lead to the following behavior, where you enter text into this HTML input, and then the model in the code, the component body, would be updated. If this body would be, or if this object, this bound object, would be updated somewhere else, this would also be reflected in the input element. So it's two-way, listening and sending it into. Of course, you will see all of these data binding methods in action throughout this module. Before I come to property and event binding and two-way data binding though, I want to have a closer look at string interpolation. Now, in order to do this, I will get rid of all these components here and of that import, as well as the directives metadata here, and of the styles too. I don't need them. And I'll get rid of this other folder because I don't need those components anymore. Instead, I will create a new component, so G, white space or space, and then C, a new component which I will call data binding. This file gets generated in this data binding folder. I'll get rid of this spec file of the testing file here. I don't need that. And the first thing I'll do here is, as you can see, it has a selector of FA data binding. I'll add the selector here in my template, FA data binding. As you're probably aware, I also need to add the import of my data binding component from data binding. And I can do this as I also have the index.ts file here. And then I add the directives metadata to set it up, data binding component. So I'll just save my application and you see data binding works. Great. So I'll also rename this to root component here. And now in the data binding component, I want to demonstrate data binding. So I'll get rid of that stuff here for now again. And next I will again add a property here. And I will name this string interpolation. And this will be a string. This is string interpolation. And I'll add another one called number interpolation. Let's see if that will work too. And now in the template in the HTML file, I'll output this. So I will replace data binding works with string interpolation. And if I save this, you see that we see this is string interpolation. This is how I output it. That's really how simple this is. This expression between the curly braces resolves to a string, since, well, this property is a string, and then simply renders it once this component is loaded and rendered to the viewer, to the user. Now, how does this work if I use the number interpolation. Does this work? Because that is no string, right? Number interpolation. Save this. Well, it still works, as you can see, because a number can easily be cast to a string, and TypeScript or Angular 2 does that for us. So this will work too. Everything which is a string or can be cast to a string will work here. So this is how we can use string interpolation. Next, I want to talk about property binding and thereafter about event binding. So to present both, where are they available? We can bind to DOM properties or events. So for example, on an image, the source property, which is a native property built into, well, the DOM. It's not added by Angular 2. The fact that we can bind to it is added, but the property itself already existed. The same is true for the click event. This is not added by Angular 2. These are native properties or events already existent in the DOM. We could also bind to directive properties or events. These are of course added by Angular 2. For example, the ng class directive, which you'll learn about soon, which allows you to add CSS classes to something, to an element. This is a directive, and this is a directive which needs an input to work correctly. This input is sent via property binding, something you will learn in this course, of course, too. The same would be true for the ng-submit event, which is an event occurring when we submit a form handled by Angular 2, also covered later in this course. Also not a built-in event, but instead one added by Angular 2 with a directive. Now, the next thing's kind of the same since components are directives, but to still differentiate it here, you can also bind to component properties. So properties set up in the class, in the body of your class, of your component class, can be bound or can be events, can be emit events you can listen to from outside. So these are the three availabilities you have: native properties and events, directive properties and events, and component properties and events. All of them being targetable with this property and event binding syntax. For the latter two, directive and component properties, you may use some built-in ones or add your custom bindings. For property binding, this is done with the add input metadata, which you add in front of the property you want to make bindable from outside. For event binding, well, it would be add output event name. And then this would typically be an event emitter, object or an object built into Angular 2, which allows you to fire events, because these custom events have to be triggered somehow and you trigger them by hand. This would be how you work with that. And of course, you'll see this in action in a few minutes. To show this in action, let's begin with property binding. I'll first add another heading here, which says string interpolation, horizontal line, and then we'll talk about property binding here. Let's say we have an input field here. Type text is okay. Now I want to set a default value. I could do this by adding the value attribute, which is nothing to do with Angular 2. This is default HTML code, and add text. If we have a look at this, you see text here. No Angular 2 stuff happening here at all. Now I will get rid of this text and instead use string interpolation to output string interpolation. I'm still using the default value attribute, but the text string I'm outputting is now created by Angular 2. This is string interpolation, so this is working. This is one way of doing this. Another way would be I use the value property binding. Now I add brackets around the value here. Now it's no longer a default HTML attribute. It's instead referring to the DOM value property. And I'm binding to that property by adding the brackets, which tells Angular 2 wait a second, this is no default attribute. Here we want to bind to a property, to, in this case, a property called value. And then I don't have curly braces between my quotation marks anymore because I don't need it. Now, as explained on the slides, I directly add an expression resolving to the type this value or this property needs, and this value property needs a string. Therefore, I add string interpolation, which still refers to this property set up in my component here, and passes it to this value property. Therefore, this looks like nothing changed, and it indeed yields the same result as before, where I was using string interpolation with curly braces and no brackets here. But this way, we're using property binding. Now, what's better? Well, here, it's really up to you. But oftentimes, you only have one way of doing it, or it's clear that you want to do it like this, especially when working with custom property binding, which I will show you in a few minutes. So this is how you bind to properties of HTML elements here. But it would also be interesting to see how you can bind to directive properties, right? Because I was talking about that too. So I will add another element, a normal HTML element here. Let's say I want to have the paragraph element here. And I give this a text of, is this styled? And now if I save this, it's of course not really styled, it's just text, right? So in order to style this, I can give that built-in directive Angular 2 ships with the ng class directive. Now, if I attach it like that, this won't work. This expects property binding. So I add brackets, and then this directive here, this property, expects to get a JavaScript object. So I create one with single curly braces. This has nothing to do with string interpolation here. This is just a JavaScript object, because between the quotation marks of property binding, remember that you write normal JavaScript expressions. There are some special things like you can't use the new keyword there, but in general, it's JavaScript code. Just make sure not to write multi-line code. That won't work. But as long as you stay in one line, you can write your JavaScript code. So I'm creating a JavaScript object here. And for this object, for this directive here, the key is the name of the class I want to attach. So let's say red border. And then true or false if I do want to attach it. Now, if I save this, you won't see anything. So I'll first define this class in this CSS file and give this, well, color border, of 1 pixel, solid red. And of course, here I have to select the class red border. So now if I save this file here, you can see that we get this red border, because if I inspect this element here, you can see it has this class red border attached to it. If I go over to my HTML file and set this to false and save, you no longer see the red border because it no longer has this class attached to it. And of course, you can not only hard code this like I'm doing this here in this template, but you can also do this dynamically. This false might be the result of, let's say, a method call on test, and then in the data binding component, you would have this method on test, which might return true. Save this. And you got the red border again because this returns true. And this is the expression executed here. And this, of course, is a way to allow you to write multi-line code again. So as you can see, normal JavaScript code here, for example, a method execution in the end, resulting in an object this property needs, a JavaScript object with a key of the class name and then true or false, and therefore applying this styling. Now, besides ng class, we also have ng style, which has as a key the style name. So let's say color for the text color. And then as a value, a string defining the style. So let's make that green. Now you can see that this is green text because, well, I set this up right way to write this. I could also make it blue, of course. So it works pretty similar, again using property binding here to make sure that we're passing the data this directive needs, as this directive has a property bound to the outside, to work correctly. And this will certainly become 100% clear once we start writing our own property bindings, which we'll do in the next video. As explained, it's of course nice to bind to already existing properties, but it really gets clear once you write your own bindings. So I will create a new component for this, and I'll navigate into the data binding folder because I want to create it there. Then I use ng c for create, or g for generate, c for component, and then I will name it property binding with a dash, make it flat so that it stays in the same folder, and also I want to have inline template and inline styles. So this creates two new files. I'll get rid of the test file. And here is my property binding component. Now let's say I don't want to output property binding works here, but instead what I want to output here is a value I get passed in from outside. Now I could do this using ng content like you learned before, but here's another technique. And of course you can not only pass content you want to output, but content you want to use anywhere in your application, as you might be aware. So here I will first get rid of this stuff here again. And then I want to output with string interpolation a property named result, which I will define here. And result should be a number. It's, let's say, 0 at the beginning. Now I want to set result from outside though. So I will add input metadata and import input from Angular core. And this will make this result property bindable from outside. So now I will go to the data binding component, or to the HTML code property binding, and I will add another headline here, call it custom property binding. Now below this custom property binding, I will add FA property binding, which is the selector of this property binding component. And notice how Angular CLI automatically transformed property dash binding into property binding camel case class name. So I'm importing this. Of course, now also adding the directives metadata and the property binding component, which has to be imported, of course, and also get rid of onInit here. So import property binding component from the property binding component here. And now you see that 0 here, of course, because it is set to 0 initially, right? We set this here. However, by adding input, this property can be bound from outside of this component. So I can go to my data binding component into the HTML template and add something to that selector. I'll add brackets because we're talking about property binding, and this is the syntax which tells AngularQ that property binding is in place. And then result is the name of the property I want to bind to. I'll set result to 10, and now if this reloads, you see that we get 10 here because we're now binding to that property from outside. We're passing the data, which should be shown there, from outside into that component. So you learned quite a lot about property binding. Time to move on to the next step, event binding. I will create a new component, and as you might have already guessed, I will not name it property binding, but event binding. Otherwise, I created the same way I did before. Get rid of this .spec.ts file. And in this event binding component, I'll again get rid of all the things I won't need here for now. Okay, and I will add a button here, which says click me. Now, if I click this button, nothing would happen right now. What I can do though is I can add a click listener to that button, and on clicking, I will execute the onClicked method. Now, be aware, I could also execute some code right away here. I don't have to execute a method. You may execute any JavaScript code here. However, I opted for the onClicked method, created in the body here, therefore, and I will just open an alert telling me it worked. Now, in order to really see anything, I of course have to implement this component. Therefore, I will add the import here. So this will be from the event binding component. Also add it in the directives array here. And then in the HTML file, I'll add a new horizontal line and a new heading saying event binding. And below that, I'll have my event binding component. Click me works. So here I'm binding to a default DOM event, to an event supplied by this HTML element, or by all HTML elements, by the DOM. Clicking on an element is something which is natively built in, like would be mouse over, mouse leave, and so on. So this was this native event. But in the next lecture, I'll have a look at building my own event, and of course also how to listen to that. So while it's nice to listen to built-in events, and you'll often do that, oftentimes you'll also need your own events. And I will show you how to build such a custom event and use it with event binding in this lecture. So I'll go back to the event binding component, and I'll add a new property, which I will name clicked. And this will be a new event emitter object. Now, event emitter is something I have to import here from Angular 2 Core. And this allows me to emit events and to listen to it, like the name implies. So what I want to do now is, here, when I'm clicking on it, I'm actually using my clicked event here, my clicked property, and I call the emit method. And I will emit some text. It works. Therefore, this is a generic type. I'll make this of type string. It will work without that too. And if you're not aware what generic types is, don't worry about this. Basically, this means event emitter is an object which can wrap itself around several other types. So you may emit an event with data of type string, like we're doing it here, or you may emit an event with type of being, well, a complex JavaScript object. So it doesn't care which type of data it emits, and therefore it's generic, and here we're using string. That's all I'm saying here. So now I'm emitting this event. As a next step, it would be great if someone was listening. I'll make this listenable outside of this component here. I could listen to it inside of this component right now, but to make it available outside, I'll add the output metadata or decorator here. I also have to import this here, output. With this is now listenable outside of this component. So I will go to my data binding component HTML file, and I'll also add something to this selector here, to this tag, like I before did with the result property binding here. I'll do the same here for the event, and I name this clicked, because this is the property name I used in the, well, class here. So clicked, of course, is no built-in, no native event. This is my custom event. And then, like for native events, I specify what should happen when this event appears. What I want to execute is I will execute the onClicked method, and I want to pass the data I'm emitting here. Remember, I'm emitting a string, and I can extract the data with the $event object or name here. And this is protected. You can't override this. This is the object Angular 2 will store the data passed through an event inside of. So $event is your way to extract data you pass with an event. So I'll execute onClicked and I pass this event data. So in the Databinding component, I'll therefore add this onClicked method. And I know that I will get a value of type string because that's what I'm emitting. And I can then simply output this in an alert. So if I save this, let this page reload, click me, you see the it works text. And this is how you can set up your own custom events and listen to them in a parent component to that. And this, of course, is a great way to let components communicate. For both input and output, so property and event binding, there are some additions to the syntax you already learned. For event binding, the add output here can take an argument of type string where you might specify a different name which can be used outside of this component. So internal, this property is named clicked. But let's say outside of this, so in the component listening to the event, you want to name this clickable, for example. Then you could go to the Databinding component or to the HTML file, to the template where I am listening. And now clicked would no longer work, as I can demonstrate you. Nothing happens because we renamed it to clickable, which is now the outside name of this property. So now this works again. This is a way to have differing names inside of the target component or of the component with the input or output and the external, the other components. However, it is a best practice to not really use that if you don't have to. So you may just leave it like this and use the internal property name as the external one too. The same you just saw for output does of course also work for input. Another thing which you also shouldn't necessarily use is that instead of having add input in front of each property you want to have as an input, and the same is true for add output of course, you could add the inputs metadata or outputs in the case of event binding, and then in an array have as strings all the different names or property names you want to use. So for example, you might want to use result here, and this would allow you to get rid of the add input. Now this would still be set as an input, but you don't have the decorator here, and of course you also don't have to import it from here then. And this should be inputs here, by the way. As you can already see, I'm getting this underlined, and I get an error by TSLint telling me that this is a bad practice and I should use add input. The same would be true for outputs. So while you might do this, and you can, it's a better practice to, well, revert this and use the add input decorator here like before. So with that, you learned how you can let your components communicate with each other, transfer data, listen to events, and so on. Of course, there are other ways too. You will learn about them in the services module, but this is a very powerful and important thing. And property and event binding, as well as string interpolation, are things you will use a lot, really a lot. Now, to come to the last way of data binding, two-way data binding, be aware that, as I already explained, it's not the default in Angular 2, and it isn't for a reason, because it is slow and it has some problems. Nonetheless, if you want to use it, and you'll learn that oftentimes you're fine without using it, but if you want to, this is how you do it. I will create a new component and I will name it two-way binding. Again, will be flat with inline template and styling. I'll get rid of the test file. And inside of this, I'll create a new input. So normal HTML element, get rid of this starting text here. Don't need the styles. Don't need on init and so, of course. So get rid of all of that. You'll learn what that on init thing means soon. And with this, I want to bind what I enter here with two-way binding. So I will create an object here. Let's name it person. And person should simply be a JavaScript object. I'll use the literal notation here, which will have a name. Let's say Max by default, so my name, and an age. So 27 in my case. So this is the person, and I want to bind this input here to the person's name. I use brackets and parentheses and between ng model to indicate that I want to bind to a model that I want to use two-way data binding. And then between quotation marks, just the model to which I want to bind. So here to the person and then to the name. So dot notation here to access this field. This already set up two-way data binding. And to demonstrate this, I will duplicate this simply. And now if I implement this by adding the import, two-way binding component, what's the name? Two-way binding component is right, like this. Did I mistype here? Two-way binding component, yeah. So now add it here to the metadata, to the directives metadata, and then of course, as before, oops, order. I'll add two-way binding, save this, let it reload. And here you see the two import fields at the bottom. Now that might be a bit hard to see though. Let me quickly do some cheap hack in here. Add a couple of empty lines just to bring it up a little bit. So these are the two fields, and if I change it in one of them, see that it changes in both of them. And this is really all that is to it. It's two-way data binding. Both fields are bind in two directions, which means if I change it in one field, it is sent to this property and updated there. And if I update this property from somewhere else, like from the other input field or the other input element, it's also reflected in the first one, because again, it's two-way data flowing out of it and into it. So where with property binding, we only send data into something, and with event binding, we get data out of something, here both directions are active, which again is two-way data binding.